Okay, so, oops, I'm on the wrong slide. We're going to look at this one, which I already have worked out for you. I'm just going to walk you through it, okay? Just to kind of make this video a little quicker. So we're dealing with this equation right here. 4 sine 1/2 x equals 3. Noticing right now that the angular frequency here is 1/2 x, or 1/2, excuse me. So that means we need to adjust this original interval, right? So before I even get started, I want to know what's the original interval, which is right here from 0 to 2 pi. That means we're in radians, and it does not say to approximate, but we have to approximate in this case, so that's what we're going to do. And so I'm going to start. 4 sine of 1/2 x equals 3. Start by isolating this function right here. So I'm going to divide both sides by 4. And now I'm down with sine of 1/2 x equals positive 3/4, right? So now I want to figure out my quadrants. You can do that, chart views, all sine, tangent, cosine. Sine's positive in the first and the fourth quadrant. So I know I need to be in quadrant 1 and 4. And I like to identify that, 1 and 2, quadrants 1 and 2. I like to identify that pretty early so I know where my angles are. And I also need to deal with this angular frequency of 1/2. So I have to take my original interval here and adjust it by 1/2. I want that middle part of my adjusted interval to be 1/2. So I distribute that 1/2 into all 3 of those terms, and I have this interval right here. I also, again, like to, this is pi, so it's about 3.14, and that's going to help me as I find coterminal angles later. Now I can turn around and take the inverse sine of those sides, right? So taking the inverse sine will isolate the angle inside of this function. So now I'm left with 1/2, right? 1/2 right there. And inverse sine of 3/4 here leaves me with 0.84. Okay, at this point, we are not going to, so the screen, I'm not going to touch that 1/2 x yet. What we want to do is now find as many possible angle intervals as I can to continue working with this. So, oops, see if I can get down there. Hopefully this doesn't mess the video up. Okay, so where are we at here? All right. So I take the inverse sine of 3/4 and I get 0.84. 0.84 is a reference angle as well as a critical angle. So I'm going to sketch that first quadrant angle right here, 0.84. And then I'm going to turn around and find that second quadrant angle right here. So same reference angle, 0.84, 0.84. So I'm going to subtract 0.84 from pi. And that's going to give me my second quadrant angle here, which is going to be 2.3. At this point, what you want to do is, again, you're looking for coterminal angles, right? Before we deal with this 1/2, before we touch this blue 2 right now, you need to look for coterminal angles. So remember, our interval that was adjusted here stops at 3.14. So any coterminal angle with 2.3, right? If I add pi radians to that, pi is 3.14. 3.14 plus 2.3 is, I'm already outside of the interval, right? As soon as I add that 3.14. So in this case, there are 2 solutions here. We've identified them, 0.84, 2.3. There's no reason to add coterminal angles because we're going to go outside of that original or this adjusted interval right away. Once you determine that, then you can turn around and now isolate the x from the 1/2 x, and now you go through and you multiply all the angles by 2, leaving us with 1.68 and 4.60 radians. And that's our solution process when the angular frequency of the equation is anything other than 1.